Hi everyone. In this session, I'm just going to solve one more question, and this time I'm going to solve question from semiconductor physics. That is my favorite subject, and I really like to solve question based on semiconductor physics, where many students struggle solving a kind of question, right? Many gate aspirant. Okay. This question I have taken from GATE 2024, and this was a question which was asked for the first time. And if somebody is not good at concept, right, I mean their concept is not good, right, they were not able to solve that question, right, in gate examination. So you can say that whatever data was there that was matching, you can say 95% students were not able to solve that question. Okay, so I'm just going to show you that question, and you can also see the thumbnail. The topic is incomplete ionization, right? So when there is 100% ionization, so till now in the gate examination, if you look at previous year questions, right, only question that has been asked from the 100% ionization, or we call it complete ionization. But this time in gate 2024, right, the question was from incomplete ionization, and this kind of concepts are not covered everywhere. In fact, only if something is covered also, but the numerical problem is not done, right? So students do not have enough practice to solve this kind of question, though that question was not difficult at all. I'm just going to show you how to solve that question, right? So let me move to the screen here. So this question was asked. This question was asked in GATE 2024 in electronics paper. So hopefully topper might be able to solve this question. But most of the students, since if you look at the difference between topper marks and the second topper marks, there is a 10 marks difference almost, right? 10 marks. So it means that many gate aspirant from electronics and communication branch were not able to solve this kind of question, right? So let's see. Question is given here: a non-degenerate n-type semiconductor. So from the very first line, what you understand? What is the meaning of non-degenerate n-type semiconductor? So if something is, let's say any semiconductor is there, right, and we call it degenerate semiconductor, it means the doping is quite high. Okay, doping is going to be quite high. Remember that. But they have mentioned here non-degenerate n-type semiconductor, right? So doping is not that high. Okay, I would say here. And if doping is not so high, means the gap between EC and EF will be certainly, you can say it is given also in this question. So a non-degenerate n-type semiconductor has 5% neutral dopant atoms. You see here they have given 5% neutral dopant atom. Okay, so you have to understand that out of 100%, 5% atoms, dopant atoms were not ionized. Okay, understand? Let's say there is 100% ionization. 100% ionization means whatever you are doping, right? Let's say you're doping phosphorus in the silicon atom. Okay, in silicon semiconductor, you are doping what? Phosphorus atoms, right? So the number of electrons will be equal to what? The dopant, you can say donor concentration, right? If there is 100% ionization, right? So whenever you introduce some sort of impurity into the semiconductor, so what kind of changes that we get to see in the energy band? Let's say this is the EC, this is EV. Okay, and if it is an n-type semiconductor, certainly the Fermi level is going to stay near the conduction band, below the conduction band. So this is going to be your Fermi level, that is EF, and that gap is also given. Okay, so its Fermi level is located 0.25 electron volt below the conduction band. Means this gap they have given is, which is 0.25 electron volt. Okay, and this gap determines the concentration of electron, as we know. So non-degenerate means the doping is not that high. Okay, n-type in the sense that the donor constant, the you can say the Fermi level is going to you know stay near the conduction band. There is a spacing 0.25 electron volt, okay, below the conduction band, and the donor energy level ED. So you should know that when we introduce doping into the intrinsic semiconductor, so new discrete energy level is going to get introduced. Okay, whenever you go, let's say you are doping with pentavalent impurity or phosphorus impurity, you can say n-type doping you are doing. N-type doping in the sense that you have to introduce phosphorus, right? So phosphorus, when you are introducing, so there will be new discrete energy level. Okay, there will be new discrete energy level which is going to be there below the conduction band, but it is going to not that close. Okay, not that close. Okay, if it is going to be very close, okay, then what will happen? At room temperature itself, all the donors are going to get ionized, but this time they have given the question here, only 5% neutral dopants atoms are there, means 95% has got ionized. Okay, so there is a gap between EC and ED, right? Okay, and that gap should be small enough, right? It should not be large enough. Okay, this gap should be small enough, right? Okay, but as far as the question is concerned, in case of 100% ionization, all the donor concentration, all the donor, you can say, don't all the donor atoms are going to contribute to free electron, you can say, right? They will participate in conduction. So this is the story here. When you dope the semiconductors, okay, let's say you have got the intrinsic semiconductor, you're going to dope it, right? And if you consider 100% ionization, then the number of electron, or you can say the concentration of electron, is going to be equal to the donor concentration, Nd, right? So let me write all those things. The case one is going to be what? If case one I'm going to consider, which we know already, and most of the classroom coaching, if you look at, they teach always these things, right? So let's say there is a 100% ionization, 100% ionization, right? If there is a 100% ionization, then what will be there? The electron concentration is going to be equal to Nd, right? In fact, you can say Nd, okay? Electron concentration is going to be equal to Nd, and which is nothing but Nd plus, you can say. That will be equal to Nd plus, right? Okay. This is 100% ionization, right? Okay. If you look at the fraction also, Nd plus by Nd, you will get 1. So what fraction of donor atoms got ionized? 100%. Okay. 100% atoms are going to get ionized. So concentration of electron is going to be equal to Nd, which is Nd plus, right? Okay, if you look at the polarity of donor concentration, that is going to be positive only, right? Okay, all the electron has got into conduction band from the donor energy level. So let's say this is a, always keep energy diagram with you, right? You know that whenever Dheeraj sir teaches, uh, electronic devices, he always take the help of energy band diagram, right? So this is the situation. Let's say your ED is here. This is ED. So all the electron has got here, all the electron in case of 100%. Let's say 100 donor atoms are there. So there will be 100 electrons. Let's say 200 donor atoms are there. You are introducing 200 donor atoms. So there will be 200 electrons, right, in the conduction band, and they will participate in conduction. Okay. This is the story of 100% ionization. But let's say there is an incomplete ionization. Okay. Not 100% donor atoms are contributing to free electron. Not 100% donor atoms are getting ionized because of low temperature or whatnot, right? Okay. So this gap, remember that. Let's say you are introducing 100 atoms, 100 phosphorus atoms, but they are not getting ionized. Only 60 got ionized, right? 60%, you can say. 100 out, okay? So 60%. Understand the fraction that is getting ionized. So in case of incomplete ionization, right, that will be case 2. The question was asked from the case 2, right? Incomplete ionization. Incomplete ionization. Okay. So what is the story here? This topic is not covered properly, guys. Anywhere if you look at any notes, anything, you look at anything, right? This topic is not covered. That was the reason most of the students were not able to solve the question. In fact, nowadays nobody refers textbooks like SMG or Neiman or any other textbook period, or so many books are there, right? सो आप उसको रेफर कर सकते हैं, वहां से कॉन्सेप्ट सीख सकते हैं, लेकिन उस कॉन्सेप्ट को यूज कैसे करना है क्वेश्चन सॉल्व करने में, क्योंकि ये न्यूमेरिकल आंसर टाइप क्वेश्चन है, ठीक है, तो थोड़ा सा तो आपको समझना पड़ेगा, तो इसीलिए मैं थोड़ा आपको कॉन्सेप्ट बता रहा हूँ, ठीक है। इनकम्प्लीट आयोनाइजेशन में क्या होने वाला है, एज आई टोल्ड यू दैट, लेट्स से 100 donor atoms got introduced into the intrinsic semiconductor when you were doping, but only 60 got ionized. Okay, like they converted into electron, and 40 were not ionized, right? So here in this question they have given 5% dopants are neutral, okay, they are not ionized. So 95% got ionized, okay. So remember that n will be equal to nd. This will be always true. Okay, this is going to be always true whether 100% ionization is there or incomplete ionization is there. N is going to be equal to nd. That is always true. But what is not true is it will not be equal to nd, guys. Nd plus. Remember that. Okay. In case of incomplete ionization, okay, it will not be equal to nd plus. I hope this makes sense to all, right? So n will be equal to nd, but nd plus will not be equal to nd. Remember that. So what fraction of electron got ionized? How to find that? The fraction of, you can say, fraction of dopant atoms got ionized. Fraction of dopants are ionized, you can say, okay, ionized, is going to be found, you can find out with the help of nd by nd, okay, nd plus by nd. See, if nd plus is equal to nd, it means complete ionization, so you will get 1, right? The fraction is going to be 100% ionization. But nd plus upon nd is going to be equal to what? Again, you can take the help of energy band diagram, so I'm just going to draw here. Okay. So this is EC, this is EV, and there is a Fermi level EF, and there is a donor energy level, that is ED, right? So this gap is going to determine, okay, the ED minus EF gap is going to determine the fraction of dopants which are ionized, right? So ND plus by ND is going to be equal to 1 upon 1 plus. There is a one important factor which comes into picture, that is called as degeneracy factor. Okay, this is G is nothing but degeneracy factor. This comes because of spin. Okay, there will be spin of, so 1 plus G times exponential this gap, you have to take EF then ED. So EF minus ED by KT. Okay, this is a formula that you have to use to solve the question. Okay, fraction of dopants, donor dopants, so fraction of donor. Okay, I'm talking about donor atoms, right? We are talking about n-type semiconductor, right? So this is a formula that you have to use, and each and every information is given. We will solve that question also. Let me give you one more situation. Let's say that what fraction of acceptor atoms got ionized, right? So in that case, in case of p-type, the fraction that we can compute here is Na minus Na will be equal to, remember this point, let's say this is nothing but EC, this is EV, okay, and this is the Fermi level now, okay, going to stay near the valence band, okay, and once you introduce the acceptor atoms, right, okay, like you can say boron, okay, so that new discrete energy level is going to be there, that is nothing but acceptor, okay, energy level, understand? So this gap is going to determine these fractions. What is that fraction? 1 upon 1 plus G times exponential, okay, again you have to maintain the same EA minus EF by KT. Okay, so this formula you can use. Now let us come back to the question. So question is what, guys? Question is this. Again, I'm going to take the question. 1 minute. Yeah. So this was a question, right? Let me move myself here. So a non-degenerate n-type semiconductor has 5% neutral dopant atoms. 5% means 95. Let's say 100 dopants are there, 100 donor atoms are there that you introduce with the help of doping, right? Doping is a phenomena, okay? Understand? So only 5% are not ionized, okay? 95% are ionized, right? So you can say that 95% means 95 electrons are free to participate in conduction. 5 only are sitting, you can say they are not ionized. Okay, so that n equal to nd will be always correct. Whatever is ionized, they will be electron, number of electrons, right? But nd plus will not be equal to, right? Remember that. So let's say here they have given 5% neutral dopant atom. What is the meaning of that? 5% neutral dopant atoms, meaning what? 90% got ionized. Okay, 90% got ionized. Okay, please remember that. Okay, so we can again write the formula nd plus by nd. It is not going to be 1 then. This fraction will never be 1. Remember this. Okay, this is very important. And this is nothing but kind of probability only, right? We have seen the probability Fermi-Dirac. Okay, Fermi-Dirac is the same kind of thing, right? So 90% got ionized in the sense that and 1 by 1 plus g times exponential. Again, you can draw the energy band diagram if you want to. Okay, remember that. And there is a ef, right? And there is a ed. This gap, ef minus ed, right? Ef minus ed by kt. Please remember this. Okay, you have to always take from bottom to up. Okay, go from bottom to up. Otherwise, if you're going to take ed minus ef, then you have to put negative sign, right, in the exponential, right? So this is given. What is this? This is nothing but 0.95 equal to. Okay, in the its Fermi level is located 0. So this gap is also given, that is EC minus EF gap 0.25 electron volt below the conduction band, and donor energy level ED has a degeneracy of 2, right? So there is a spin, okay, that is 2 here. Okay, so degeneracy factor is because of spin, that is 2 times exponential. Okay, EF minus ED, right? So we are not given EF minus ED, so we can find out EF minus ED by KT is given. We will put KT value in the end, right? In the end, we are going to put KT value. Okay, I think this is clear for all, right? So assuming that the thermal voltage is also given, that is 20 millivolt. Okay, that will be 20 milli electron volt if you try to find KT. They are asking you to find the difference EC minus ED. So what they are asking is this. So if you are able to find this, you see guys, if you are able to find ED minus EF, then you have to subtract. That's it. You will get the answer, right? Because the total EC minus EF is nothing but EC minus ED plus ED minus EF, right? It's a very simple math, okay, from this energy band diagram. It is very clear. So can we solve this? Yeah. So let me copy this guy and solve it. I think we can copy. Yeah. Again, I'm gonna write. So आप इसको लिख सकते हो 0.95, which is 1 by 1 plus 2 times, right? That was G exponential EF minus ED by KT. Okay. Now you can just multiply, and so it will be nothing but 0.95 plus. Don't solve anything at this moment, right? Just keep multiplying, keep simplifying the. Okay, and you can use at the end of the day calculator, right? If you're going to multiply it, so you will waste your time, because at the end of the day, what you will do, you will use online calculator. That is what electronic devices question, that is how electronic devices question must be done, right? अगर वो numerical question है तो आप पहले पूरा सिस्टम रेडी कर लीजिए, पूरा स्ट्रक्चर रेडी कर लीजिए, लास्ट में वैल्यूज पुट करिए, अदरवाइज यू माइट लूज टाइम एंड यू माइट मिस्टेक एज वेल. ठीक है, तो ये कितना हो जाएगा 2 times 0.95 एक्सपोनेंशियल टू द पावर EF minus ED by KT equal to 1. Now you guys can take this guy this side, so that is nothing but what, that is 0.05 only, and you can take also this guy down, right? So it is nothing but exponential. In my case, I will directly solve this, but I'm just showing you EF minus ED by KT, which is nothing but 1 minus 0.95 upon 2 into 0.95, which is nothing but 0.05 upon 2.0.95 2 into 0.95. Don't solve it, okay? Don't simplify this. Let's say this is a natural kind of exponential function, right? So it goes to that side, so it becomes natural log. So and kt मल्टीप्लाई कर सकते हैं, so that becomes ef minus ed equal to kt ln, okay, 0.05 अपॉन 2 into 0.95. ठीक है, अब kt भी दिया हुआ है, kt is given as what, 20 milli volt, that is 20 milli electron volt you can say. So इसको आप सिंपल उसमें कन्वर्ट कर लीजिए, that is nothing but 0.20 मिली वोल्ट को आप लिख सकते हो 0.02, ओके, वोल्ट, विच इज नथिंग बट 0.02 ln. अब इसको आप सॉल्व कर लो, 0.05 अपॉन 2 into 0.95, right? How to solve this? That is a question also. So I'm just going to show you how to solve this, right? कैलकुलेटर में रख के दिखाते हैं आपको सारा, ठीक है? So let me show you the screen. आपको पूरा कैलकुलेटर का फीलिंग देने वाले हैं ये calculator. I think everybody is able to see here, right? So what are the value that is given? So first of all, we have to start inside the parentheses. So 2 into 0.95 is given in the denominator, so we can take that. So 0.95 into 2 इक्वल करना है, फिर उसको आप रेसिप्रोकल कर सकते हो, then multiply 0.05, देन टेक द लॉन, नेचुरल लॉग यहाँ पर है, ठीक है, सिंपली निगेटिव आ गया, डरना नहीं है, ठीक है, टाइम्स 0.02 बिकॉज दैट इज केटी वैल्यू. यू गॉट दिस, राइट? सिंपल, ओके, लाइफ इज वेरी इजी ना. So you got how much? Negative 0.07275 something you got, right? Then what do you have to do? This is not the answer, guys. They are asking you to compute what? Let me come back to the screen and show you what they are asking. Okay. So let me show you that. So they are asking you to compute the gap EC and ED, the difference EC minus ED. So this is nothing but EF minus ED. Please remember this. But what they are asking is EC minus ED, right? Okay. So how can you write EC minus ED in terms of, you can include EF as well. So EC minus EF, you can say, then EF minus ED. Can you write like this? Yeah, because EF get cancelled. EC minus EF is given in the question, right? So we can go back and check what is given. EC minus EF is given as 0.25 electron volt, right? So इसको आप लिख सकते हो 0.25, and this is already we have computed, that is minus 0.07275. So what is the next criterion? What is the next calculation we have to do? We have to just add 0.25, okay? That is the answer for the question. So let me get back to the calculator again, and I'm just going to get back. Oh yeah, this is what the calculation is, right? So we have to just add it. So plus put equal sign again, right? Because equal press करने का मतलब क्या है? Multiple time if you are pressing equal means that is stop, okay, kind of thing, right? Plus 0.25. देखो तो आपका आंसर कितना आता है, देखो 0.177 काइंड ऑफ, राइट? ठीक है, तो इसको आप क्या कर सकते हो, अगेन लेट मी गेट बैक टू द ओके. So 0.177, that is nothing but you can approximately say that 0.18 electron volt, okay? So this was a question, and answer key, if you look at answer key, okay, the answer key was also given like 0.172, 0.172, 0.19, exact answer you are getting, okay? So this was the very good question. I hope everybody might have understood. So next year we might expect related to p-type doping, right? Incomplete ionization in p-type doping, in p-type semiconductor, right? That Na minus by Na. तो आप देखो मैंने क्या किया है, इसमें कुछ भी नहीं था, बस आपको थोड़ा सा मैनिपुलेशन में गलती होती है. And in devices, basically, we always make mistake in terms of manipulation. We always we get lost into mathematics because nobody teaches those things. ठीक है, मुझे पता है, ठीक है, since I have been spending my time in academics only since many years. Okay, I insanely spent my time in electronic and communication area, right? From the past 4 5 year, I'm also spending time in computer science and AI, but machine learning, बट डिवाइसेस, ये सारी चीज़ें से मैं पिछले 10 साल से 10 से 12 साल हो गए कम्प्लीटली, राइट? तो वही मैं देख रहा हूँ कि यस, यू नीड टू मास्टर दिस सब्जेक्ट, लेकिन मास्टर तो कर लोगे, आपको सब आने लग, बट सॉल्व कैसे करना है क्वेश्चन, हाउ मैथमेटिक्स हैज टू बी डन, राइट, हाउ कैलकुलेशन हैज टू बी डन, दैट इज द सीक्रेट ऑफ लर्निंग इन डिवाइसेस, ठीक है? ये कोई आपको नहीं बताता, whether you accept or not, right? So we'll meet in the next session. Thank you.